In these problems, we are evaluating the limits of some rational functions. And the one thing you have to watch out for with rational functions is if the value that x approaches, if you plug that into the denominator and the denominator becomes 0, the whole thing blows up. So we have to be careful and watch out for that, and we'll try some other methods if that happens. This first one, though, I don't think that's going to happen. If you put -4 in here, yeah, the denominator is not going to be 0. So in this case, we can find the limit simply by taking this value, x approaches -4, plugging that -4 in for x, and then doing the calculation. So this would be -4 minus 4. -4 squared is 16. 2 times -4, that's a -8. And minus 24. And let's see, I think that comes out to -8 over -16, and that would be 2. So that's our limit of this rational function as x approaches -4. It's 2. Let's try another one. Here we have the limit as x approaches 11, and we have this rational function. I can see that I'm not going to get 0 on the denominator if I plug in 11 here. 11 cubed is some huge number. We're not going to get 0 down here. So all I need to do is plug in that 11 for x and crank this out. So let's try that. Let's see. 11 squared is 121. And 11 cubed is 1,331. And then I have to figure out this fraction. Let's see, 121 minus 9, that's 112. 27 minus 1,331 is -1304. And you'll have to do some reducing here. I think what you come up with is -14 over 163. And I think those are the simplest terms. So that's our limit as this function approaches 11. All right, let's try one more. In this one, we're asked to find the limit as x approaches 2 of this function. And you can see that at the point x equals 2, the denominator here is 0. So this function is not defined at x equals 2. But that doesn't mean it doesn't have a limit as x approaches 2. So very close to 2, maybe it's converging on the same value. How can we figure this one out? Well, my first step with a rational function like this would be to try to do some factoring. And I notice I've got a difference of cubes on the top and a difference of squares on the bottom, so I may get somewhere with some factoring. Remember, the difference of cubes states that a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. That's the difference of cubes. So if I apply that here, a is x and b is 2, because 2 cubed is 8, we would get something like this: x minus 2 times x squared plus 2x plus 4. So I factored the top there, and I suppose I could do some more factoring here, but I'm going to work on the bottom here and see how far I have to go. Now here we have a difference of squares, and remember, a squared minus b squared equals a minus b times a plus b. That's the difference of squares. So let's go ahead and do that here. In this case, a is x squared and b is 4. So we would get x squared minus 4 and x squared plus 4. And that doesn't give me anything I can cancel, oops, x squared, anything I can cancel yet, but this is another difference of squares here, so we can actually rewrite this one as x plus 2 and x minus 2. Aha, now this x minus 2, this x minus 2 will cancel. And at this point, I'd like to see if I can plug in a 2, and will I get 0 on the bottom. It doesn't look like it because I've got all positive things down here. So let's go ahead and plug in 2 and see what we get. On the top, 2 squared is 4. 2 times 2 is 4. And then we have plus 4. On the bottom, I have x squared, so that's 4 plus 4 times 2 plus 2, which is times 4. So 4 times 8 is 32 on the bottom. And we have 12 on the top, so that is 3/8. So in this case, even though the function itself is undefined at 2, it has a limit as x approaches 2 of 3/8. So that's a little bit of work on calculating limits of rational functions. My name is Larry. I'm a teacher at EdVision's off-campus school. It's an online project-based 7th through 12th grade school in Minnesota. If you're interested, you can check us out on the web at lovethischool.org. Thanks.